This is a video from section 3.5. The directions say to find dy dx by implicit differentiation. We're going to start with problem 17. Suppose we're given 2x e to the y plus y e to the x equals 3. And I want dy dx. And so just like in the other video, we need to differentiate both sides with respect to x. So the derivative of 2x e to the y plus y e to the x with respect to x is equal to the derivative of 3 with respect to x. And so to differentiate the first term, we need to apply the product rule. So I'm going to write the first function, which is 2x, and I'm going to take the derivative of e to the y with respect to x. So by the chain rule, I'm going to get e to the y times dy dx. And I'm going to go plus the second function, which is e to the y, and I'm going to multiply by the derivative of the first function, and so the derivative of 2x is 2, and I'm going to add the derivative of y e to the x. Again, I'm going to use the product rule, so I'm going to write y times e to the x plus e to the x times dy dx. I'm going to set this whole result equal to 0. Now, I need to collect the terms that involve dy dx on one side, so I'm going to collect that term along with this term, and that's going to be on one side, and then everything else gets moved to the other side. So 2x e to the y dy dx plus e to the x dy dx is, and then I'm going to move 2e to the y and y e to the x over to the other side. So this is negative 2e to the y minus y e to the x. Factor out a dy dx. So when that happens, in the brackets, I'll get 2x e to the y plus e to the x. And this is equal to negative 2e to the y minus y e to the x. Solving for dy dx, I get negative 2e to the y minus y e to the x in the numerator, and in the denominator I get 2x e to the y plus e to the x. And this is problem number 17. Let's take a look at problem number 19. Suppose square root of x plus y is equal to x to the fourth plus y to the fourth. And I'm going to differentiate both sides with respect to x. So if you don't mind, I'm going to rewrite square root of x plus y as x plus y to the 1/2. So I'm going to find the derivative of x plus y to the 1/2 with respect to x, and set that equal to the derivative of x to the fourth plus y to the fourth with respect to x. So by the chain rule, I get 1/2 of x plus y to the negative 1/2 times the derivative of x plus y with respect to x. So x plus y is the inside function. And I'm going to set this equal to, now the derivative of x to the fourth is 4x cubed. the derivative of y to the fourth is 4y cubed, but you have to multiply by dy dx. Okay, and so here I get 1/2 of x plus y to the negative a half times the derivative of x with respect to x is 1. The derivative of y with respect to x is just that, dy dx. So we get 1/2 times x plus y to the negative a half times the quantity 1 plus dy dx. And we're going to set this equal to 4x cubed plus 4y cubed dy dx. Now, I'm going to distribute the 1/2 of x plus y to the negative a half inside. So I get 1/2 of x plus y to the negative a half plus 1/2 of x plus y to the negative a half dy dx equal to 4x cubed plus 4y cubed dy dx. Now, I want to collect the terms that involve dy dx on one side, so that's this term, and I need to collect this term on one side of the equation, and I want to put everything else on the other side. And at the same time, I'm going to do the following. So I'm going to write this as 1 over 2 times x plus y to the half minus 4x cubed. That's on the left side. And on the right side, I get 4y cubed dy dx minus 1 over 2 times x plus y to the half times dy dx. Now I'm going to clear the fraction because it's just easier to manage. And so I'm going to multiply both sides by 2 times x plus y to the 1/2. So I get 1 minus 4x cubed times 2 times x plus y to the half on the left side. On the right side, I get 4y cubed times 2 times x plus y to the half dy dx minus dy dx. And so 1 minus 8x cubed square root of x plus y is 8 here. In fact, what I'm going to do is factor out a dy dx on the right-hand side. So if I factor out the dy dx, I get 8y cubed square root of x plus y minus 1. And then if I solve for dy dx, I am done. So dy dx is 1 minus 8x cubed square root of x plus y divided by 8y cubed square root of x plus y minus 1. And that's how we do number 19. So what I want to do now is I want to take a look at 23. If f of x plus x squared times f of x to the third equals 10 and f of 1 equals 2, the question says find f prime of 1. So That's a nice question. Now, we're going to differentiate both sides with respect to x. So I'm going to get f prime of x plus, now I'm going to write down the first function, which is x squared. So this is classic product rule. And I'm going to take the derivative of the second function, which is f of x to the third. So there's some chain rule involved. So this is 3 times f of x raised to the second, okay, times f prime of x. And then I'm going to go plus f of x cubed times the derivative of x squared, which is 2x. And I'm going to set that result equal to 0. Now, what I'm going to do is I'm going to let x equal 1. So f prime of 1 plus 1 to the second times 3 times f of 1 squared times f prime of 1, okay, plus f of 1 to the third times 2 times 1. That's going to equal 0. Now, we don't know f prime of 1, so we're going to leave that alone. So I get f prime of 1 plus 1 times the quantity, and then I get 3 times f of 1, which is 2, squared, times f prime of 1. And then I'm going to add 2 to the third times 2. And I'm going to set this result equal to 0. So you just have to tread very carefully. So you get f prime of 1 plus. Now, 2 squared is 4. 4 times 3 is 12. So we get 12 f prime of 1 plus 16 equals 0. So that says 13 f prime of 1 is equal to negative 16, and that says f prime of 1 is negative 16 thirds. Oh, excuse me, negative 16 over 13. And that's how you do problem 23. Suppose we gave this one. Find y double prime by implicit differentiation. Simplify if possible. And we're going to take a look at 39. Suppose we have x squared plus 4y squared equals 4. Now, you need to find y prime before you find y double prime. And so I'm going to differentiate both sides with respect to x. So we get the derivative of x squared plus 4y squared with respect to x is equal to the derivative of 4 with respect to x. So we get 2x plus 8y times dy dx is equal to 0. Okay. Now from here, we're going to solve for dy dx. Now, 8y dy dx is equal to negative 2x dy dx is negative x divided by 4y. Now, I'm going to find the second derivative. So I'm going to label it this way, and we can apply the quotient rule. So write down the bottom function, 4y, take the derivative of the top function. So the derivative of negative x is negative 1, and I'm going to subtract the top function, which is negative x, and I'm going to multiply by the derivative of the bottom function, which is 4 times dy dx, and I'm going to divide by 16y squared. So in other words, I'm going to divide by the bottom function squared. So if I take the second derivative of y with respect to x, I get negative 4y plus 4x dy dx. When you subtract a negative, you add. And I'm going to divide by 16y squared. Now, remember, dy dx is negative x over 4y. We double check again. Yeah, negative x over 4y. So I'm going to replace dy dx with negative x over 4y. So when I write down the second derivative, I get negative 4y plus 4x times negative x over 4y divided by 16y squared. And I'm going to multiply both sides by 4y over 4y. And so the second derivative of y with respect to x is negative 16y squared minus 4x squared, because the 4y's are going to cancel, and I'm going to divide by 64y cubed. And so remember that y prime is dy dx. And then y double prime is the second derivative of y with respect to x. And so therefore, y prime is negative x over 4y. That's how you find y prime. And then y double prime is negative 16y squared minus 4x squared divided by 64y cubed. And that'll conclude this video for section 3.5. We looked at problems 17, 19, 23, and 39. Thank you.